This is the new house to be built for the Wilkins family. Henry and Walter have been excited about the model ever since the architect delivered it the other night. Henry, the artist in the family, likes the beauty and proportion. Walter, who wants to be an engineer, admires the balance and the massive appearance. As a matter of fact, it is the geometry of the design that pleases both of them. The problem right now is a terrace. They want to add a porch over the east end of it. By enclosing this part of the terrace, the family will have a cozy outdoor spot in which to relax. How will the porch change the terrace and the appearance of the house, though? And what about those big windows on the south? Mother wants to know, will the porch cut off the winter sun that will help warm the living room? We wouldn't want to do that. And there's one way to be sure. Let's build the porch here, change the model to match the blueprints, and try it out. The geometry that helped build the model will help us add to it. For our geometric construction, we'll need some construction tools, a set of compasses, and a straight edge. We'll also use measuring tools, a protractor, and a scale. Now let's see. How large is the model? 3/8 of an inch on the model represents 1 foot on the actual house. And the blueprints? 1/4 inch represents 1 foot. So 3/8 compared to 1/4 is how much? It looks as though the dimensions of the model are just 1 1/2 times the corresponding dimensions of the blueprints. To build the porch, we'll have to construct similar rectangles, walls the same shape as those on the plan, but with larger dimensions, 1 1/2 times as large. So, before long, the porch begins to take shape. Now we're concerned with only 2 dimensions for each side, length and width. We don't bother with the thickness of the cardboard, and we speak of the walls as plane figures, considering them to be perfectly flat. Since these plane figures are drawn to scale and have the same shape as the plane figures on the blueprints, we shall call them similar figures. For the triangle of the gable in this print, we'll have to make another similar figure, a triangle 1 1/2 times as long and as high as this one. First, a straight line. The base of the triangle only 1 1/2 times as long as the base on the blueprint. Now to measure an angle. Line up the protractor with the center point at the vertex of the angle. Line up the 0 with the initial side of the angle. All right, there's a 20-degree angle. Now, 20 degrees, but what is Henry doing? 30 degrees? It looks as though he's making the angle 1 1/2 times as big as the one on the blueprint. What kind of a triangle do you think he's going to get out of that? Doesn't match the blueprint, does it, Henry? No, angles are not drawn to scale. To make similar triangles, that is, triangles of the same shape, their corresponding angles must be equal. The size of the angles always determines the shape of the triangle. So Walter marks off 20-degree angles on the cardboard and completes the triangle by extending the sides of these angles until they meet. Remember the geometric principle of similar triangles? It has been the same for 23 centuries, since Euclid, a Greek mathematician, determined some of the principles of the mathematical science of geometry. If 2 angles of one triangle are respectively equal to 2 angles of another triangle, the triangles are similar. The base of one is 1 1/2 times as long as the base of the other. so the other sides are also in the ratio of 1 1/2 to 1. These are similar figures. Now to finish, we add drawings on paper of the porch screens. And that was easy to do. Just match each wall with a cover the same size and shape. But this east wall with the triangular gable gives trouble. We need a triangle that just matches it. And it's hard to measure length up under the gable. Well, there's another geometric principle that will help us here. How does the theorem go? If two angles and the included side of one triangle are respectively equal to two angles and the included side of another, the triangles are congruent. The figures have not only the same shape, but the same size, and all their angles and sides are respectively equal. So we make a line equal to the baseline of the gable. And with the protractor, we lay out 20-degree angles, equal to the angles of the gable. This will make a triangle congruent to the triangle of the gable, all sides and angles respectively equal. This is only one of the ways we can make congruent triangles. When two figures are congruent, it means that one can be placed over the other so that all their respective parts will coincide. Well, geometric construction has enabled us to build the porch to the same scale as the rest of the house. And the porch does look attractive, doesn't it? It fits in with the lines of the house. Parallel lines, rectangles, geometric shapes, proportion. Yes, it takes those things to make a beautiful house. But wasn't there something about symmetry? That's a geometric idea too, isn't it? The main features on one side of this line are matched on the other side. Symmetry is an exact balance of shapes and lines on each side of a central axis. And each window is symmetrical too, balanced about a center line called the axis of symmetry. If you look around you, you'll recognize geometric forms in many buildings. In a large office building, we see rectangles, parallel lines, and perpendiculars. They are there because an architect used geometry in his plans, just as engineers who lay out great railroads and highways use geometry in their work. So too do the builders of locomotives, automobiles, and machines of all kinds. What modern machine could do its work without the circle? Look at the geometric precision of the printing press, whose wheels and cylinders bring us news of the world about us. A world of geometric shapes in steel, concrete, and in nature. For we even use geometry to determine the pattern of these fields. Through a geometric arc, the sun appears to move over the earth, over our homes. And what was it Henry and Walter wanted to know? Will the new porch reduce the amount of warming winter sunlight? How does the sun move? In this pamphlet, Walter has the geometric answer. Where they live, the winter sun reaches a peak at noon of about 30 degrees above the horizon. Now, let's arrange a model sun for our model house. This flood lamp will do. We'll move it through an arc similar to the arc of the sun. It should rise in the east, like this, to a noon position in line with this 30-degree triangle. Now let's see how much light reaches the living room windows. We can see that the full afternoon sun will warm the living room through the windows in the winter. Yes, geometry helped build the porch and proved that it was practical. No wonder wonder Henry and Walter are eager to learn more about a mathematical science that is so important to all of us, the science of geometry.